Starting here in session 72, for the next few sessions, we'll be dealing with fractions and in particular algebraic fractions. But before we get into algebraic fractions, we're going to spend a little bit of time here reviewing how you've dealt with fractions up to this point, because many of the same principles apply with algebraic fractions. First of all, we have a very simple pie chart here. We have a pie that's divided into 8 sections by the green marks here that we've got going. So if the question was, how many of the pieces of pie here have been eaten, and the portion that has been eaten are referred to by the red pieces. Well, what you would do is you would count the number of red pieces that you have. That would be 2. Then on the bottom of your fraction, you would put the number of different pieces that there are in the entire pie. Well, if you counted all of those up, you would see that there are 8 pieces altogether. So one way of thinking of this fraction is the bottom number in your fraction, the denominator, tells you how many equal parts there are in something. In this situation, we have 8 equal pieces of pie. In the top part, the 2, that represents how many pieces of that 8 that you're dealing with, either by eating it, subtracting it away, taking it away, what have you. So the 2 here then represents the number of those equal parts that we're dealing with. Well, if we were to ignore the green marks for a little bit here, these 2 diagonal green marks, and just kept the 2 green marks, one vertically and one horizontally, what's another way of saying what the fraction of this piece of this pie has been eaten? Well, let's instead instead of looking at this as 8s, let's instead look at this pie as being in 4 equal sections. The only thing, once again, that we would have to do is sort of ignore that green diagonal cut and that green diagonal cut. In that case, what we would have is 4 equal parts. In that situation, then, how many of those 4 equal parts did we eat? Well, we ate 1. So we can see here that both 2/8 and 1/4 are equivalent fractions. They have the same value. It just depends on how many equal parts we're dealing with. Well, I'm not going to draw it here, but I could also say, let's take this same pie and divide it into 16 equal parts. In order to keep equivalent fractions going, how many equal parts out of the 16 must we have eaten to have eaten the same portion of the pie that we did in these other 2 fractions here? Well, we would have eaten 4 out of those 16. So we can see here that 4/16 is also an equivalent fraction. And one of the things that you learned in earlier times with the fractions is that if you have a fraction such as 2/8, you can either multiply the top and bottom of that fraction by the same number, or you can divide the top and bottom of that fraction by the same number. And when you do that, you create an equivalent fraction that has the same value. For example, we have 2/8. Let's take a look at that with 1/4. Well, what did we have to do to our 8 to get to 4? We're comparing this denominator with this denominator. Well, we had to divide it by 2. 8 divided by 2 is 4. So if we divide the bottom by 2, we also have to divide the top by 2. 2 divided by 2 equals 1. So in this situation here, we divided the top and bottom by the same number. Let's take a look at our 1/4 now. We're going to move from here over to our fraction of 4/16. When we start in our denominator, we have a 4. We take a look at our denominator over here, 16. Then we ask ourselves, what did we have to do to the 4 to get to the 16? Did we divide or multiply? Well, we multiplied, and we had to multiply by 4. So if we multiply our denominator by 4, we have to take our numerator, our top, and divide it by 4 as well. So 1 times 4 giving us 4. 4 times 4 giving us 16. So we can see equivalent fractions are created by taking your original fraction and either multiplying the top and bottom by the same number or dividing the top and bottom by the same number. Now we're going to flip the screens here and take a look at another way that we have dealt with fractions in the past, and that is that a fraction is just a special way of writing a division problem. So fractions can also be thought of as quotients or answers to a division problem. And the division problem in a fraction is always the top number, which is your numerator, divided by your bottom number, which is your denominator. 1/4 is the same thing as 1 divided by 4. So what I've done here is I've rewritten 1/4 as a division problem. 1 divided by 4. I went ahead and stuck in my decimal point and added a couple extra zeros so that we could carry out this division. If we went 1 divided by 4, we would find out that our answer is 0.25. So once again, fractions are also ways of dealing with division problems. And once again, top divided by bottom. And if you remember also earlier on in your math experience, when we reduced fractions, what we do is take a fraction and we would try to find the biggest number that we could divide both the top and the bottom by. So reducing fractions was also a way of dividing a number, a numerator and denominator, by the same number to create an equivalent fraction. Well, down here we're going to be going the opposite direction. We're going to be multiplying instead of dividing. So the question here is, if we have a fraction 4/9, we want to create another equivalent fraction to that that has 27 in the denominator. So we have to ask ourselves, what do we have to multiply the 9 by, this denominator, to reach 27, this denominator? Well, we had to multiply by 3. So if we multiply the bottom by 3, what do we have to multiply the top by? 3. What is 4 times 3? It's 12. 4/9 is the same thing as 12/27. And if we were to take this out, we're going to take our 4/9 here, and if we were to transfer that into a division problem, because remember, fraction is just another way of having a division problem, and I'm only going to take this out to a couple decimal places, we could find out that 4/9, we're going to carry out the division here. We'll bring down that 0. That is 4 as well, and that keeps going on and on forever. We have a repeating decimal here. 4/9 is the same thing as 0.44. So once again, that illustrates that fractions are also just special types of division problems. And I erase that. We'll do one more problem here, and that'll finish up the session. This time, what we are wanting to do is to reduce a fraction. Well, let's say we had a fraction such as 121 over 44. And what we want to do is reduce that fraction to lowest terms. So what we have to do is find the number, the biggest number, that we can divide both the top and the bottom by. 11 is that number. So let's go ahead and divide 121 divided by 11. That'll give us 11. We divide the top by 11. We now have to divide the bottom by 11. 44 divided by 11 is 4. So once again, this was a very straightforward lesson. We just reviewed how we dealt with fractions in earlier years, because many of these same principles will apply when we have algebraic fractions. So as a quick review here, if we had a fraction a over b, and then we multiply both the top and bottom by the same number n, when we carry that out, that answer will reduce to a over b. For example, in this example here, 4 represents our variable n. 4 is the number that we're multiplying both the top and the bottom by. A is 2 and b is 3. Well, what is 4 times 2? Well, that's 8. What is 4 times 3? 12. What does 8 over 12 reduce to? It reduces right back to 2/3. So we can see here that if we have a fraction, a over b, and then we multiply the top and bottom by the same number, we have not changed the value of that fraction at all, because we could then turn right around and reduce that fraction right back to the a over b that we started with. And lastly here, if we have a over b, which remember is also a division problem, a divided by b, that's really the same thing as taking the a and multiplying it by 1 over b. So actually, it's advantageous at times to create or to treat a division problem as a multiplication problem, and we do it by multiplying that particular number by its reciprocal. A divided by b is the same thing as a times 1 over b, and 1 over b is the reciprocal of b. And as an example of this, here we have 6 divided by 3. 6 represents A, 3 represents B. We can now split that 6 over 3 into 6, which is A, times 1 over B, and the B is 3. So 6 over 3 is the same thing as 6 times 1 over 3. Okay then, that'll finish up session 72.